In this article, finding the initial basic feasible solution using the northwest corner cell method will be discussed. Now the working rule for the northwest corner rule are: Step 1. Select the upper left corner cell of the transportation matrix and allocate minimum of S1, D1. Step 2. Subtract this value from supply and demand of respective row and column. If the supply is 0, then strike that row and move down to the next cell. If the demand is 0, then strike that column and move right to the next cell. If supply and demand both are 0, then strike both row and column and move diagonally to the next. Step 3. Repeat these steps until all supply and demand values are 0. We are going to explain this northwest corner method by one example. So determine the basic feasible solution to the following transportation problem using northwest corner rule. The given matrices, the sources S1, S2, S3 and 5 destinations D1, D3, D4 and D5. So for the sources S1, S2, S3, the supply are 4, 8 and 9. The destinations D1, D2, D3, D4, D5 have demands 3, 3, 4, 5 and 6 respectively. According to the northwest corner method, S1, D1 has to be the starting point, that is the northwest corner of the table. So each and every value in the cell is considered as the cost per transportation. Compare the demand for column D1 and supply from the source S1 and allocate the minimum of 2 to the cell S1, D1 as shown in the figure. The demand for column D1 is completed, so the entire column D1 will be cancelled. The supply from the source S1 remains 4 minus 3 equal to 1. Now from the remaining table, excluding column D1, check the northwest corner, that is S1, D2 and allocate the minimum among the supply for the respective column and the rows. The supply from S1 is 1, which is less than the demand for D2, that is 3. So allocate 1 to the cell S1, D2. Since the supply from row S1 is completed, cancel the row S1. The demand for column D2 remain 2. From the remaining table, the northwest corner cell is S2, D2. The minimum among the supply from source S2, that is 8, and demand for column D2, that is 2. So allocate 2 to the cell S2, D2. The demand for the column D2 is completed, so cancel the column and the remaining supply from the source S2 is 8 minus 2 equal to 6. Now from the remaining table, find the northwest corner, that is S2, D3 and compare the S2 supply, that is 6 and the demand for D2, that is 4 and allocate the smaller 4 to the cell S2, D3. The demand from D3 is completed, so cancel the column D3. The remaining supply for S2 remains 6 minus 4 equal to 2. So from the remaining table, the northwest corner cell is S2, D4. The minimum among the supply from source S2 and demand for column D4. So allocate the minimum 2 to the cell S2, D4. The supply for the row S2 is completed, so cancel the row S2 and the remaining demand for D4 is 5 minus 2 equal to 3. From the remaining, the northwest corner cell is S3, D4. The minimum among the supply from source S3 is 9 and demand for column D4, that is 3. So allocate the minimum 3 to the cell S3, D4. The demand for the column D4 is completed. So cancel the column and the remaining supply from S3 is 9 minus 3 equal to 6. In the last remaining cell, the demand for the respective columns and rows are equal, which was cell S3 D5. In this case, the supply from S3 and the demand for D5 was 6. So at last, nothing remained for any row or column. Now, just allocated value with the respective cell value, that is the cost, and add all of them to get the basic solution. That is 2 into 3 plus 11 into 1 plus 4 into 2 plus 7 into 4 plus 2 into 2 plus 8 into 3 plus 12 into 6. Totally, the transportation cost will be equal to rupees 153.